In this video, we're going to talk about solving rational equations. Before we begin, we kind of need to remember some basic facts about rationals and radicals and exponents. So here I have a rational expression, a raised to the mnth power. We can rewrite this rational expression, which is a base raised to a fractional power. We can rewrite it in its radical form by taking the denominator n, and it becomes the index of my radicand, and the numerator m becomes the power. Now I usually write it as this. Again, we have our rational over here. N becomes the index, and m becomes the power. Okay, that's the first thing you want to remember. Another thing you want to remember is on the rules of exponents, what happens when I have some base raised to a power that is also raised to another power. This is the power rule for the rules of exponents. If I have a power to a power, remember that that allows me to then just multiply the two powers together. And that's going to be a rule that we're going to be using when we solve these rational equations. Another thing you want to be aware of when you're solving rational equations is what happens if the numerator in my equation is even, the numerator of my variable I'm solving for. If it is even, we're going to end up with a positive and a negative value for solutions. If the numerator is odd, we only end up with that same, with the one solution. Okay? And that really has to do with the fact that if I take the square root of something, I can get positive and negative values. Or if I take the fourth root of something, I can get positive and negative. But if I take the cube root of something, I just get the one term. Alright, so let's jump down here and let's see how to solve this equation we have going on. X plus 5 raised to the 3/2 is equal to 8. Now let's first talk about how many proposed solutions will I have. We can determine that by looking at the numerator on my variable, and the numerator here is odd. Since the numerator is odd, we're going to have one proposed solution. Okay, so that's, we know how many solutions to look for. Now where do we go from here? Well, if I were to raise both sides of the equation by the reciprocal of this power, so 2/3, then remember when I raise a power to a power, I multiply those two numbers together, and in this case that's going to give me x plus 5 raised to the first power, because 3/2 times 2/3 is 1. On the right hand side, I end up with 8 raised to the 2/3 power. I can't do a whole lot with it in its rational form, so I'm going to go ahead and change this into a radical to see if I can simplify it. Remember that the denominator, and again this is where I usually start, it helps me remember what's going on. The denominator becomes the index, so we're talking about the cubed root of 8 squared. Okay, the cubed root of 8 squared. Now I can take 8 squared, okay, 8 squared, which is 64, and I know my cubed roots, the first couple of them, and I know that the cubed root of 64 is actually 4. Okay, if you don't know that, then you can actually take your calculator, and since I'm here, we'll just show you, and I can raise that 8 to the 2/3 power. So 8 and you want to, you can do 2 divided by 3, and if it's a perfect root, it's just going to give you back the value. Okay, so I know that it's 4. So we have x plus 5 is equal to 4, and when we solve, we're going to subtract 5 to the right hand side, and I find x is equal to a -1. Now you do want to check the solution over here, and I don't really feel like putting it in the calculator. I think I can do this pretty quickly by hand, so I'm going to just doing the check, I'm going to say -1 plus 5 raised to the 3/2, and I want to know, is that equal to 8? Well, -1 plus 5 is 4 raised to the 3/2. Is that equal to 8? Well, I don't know. Remember, we can write this as 2 is the index. So it's the square root of 4 cubed. And 4 cubed, that's 4 times 4 is 16, times another 4 is 64. So we're looking at the square root of 64. Is that equal to 8? Well, yes it is. I know that it is. Okay, so it's not an extraneous solution. It is in fact, -1 is in fact the answer we wanted. Let's try that again over here on this problem. So I have 8x raised to the 5/3 minus 24. Okay, so on this one again, looking at the number of possible solutions, since the numerator on my variable on the rational portion, since the numerator is odd, I'm looking for one solution. Now how do I go about doing that? I can't just take the 3/5 root or raise both sides to 3/5 because I have too much going on here. What we want to do is we want to try to isolate my variable before we ever raise anything to a power. So I'm going to add 24 to the right hand side. I get 8x to the 5/3 equals 24. Still, I can get the variable even further by itself by dividing both sides by 8. So I now have x to the 5/3 is equal to 3 because 24 divided by 8 is 3. It is at this point that I can raise both sides to the 3/5 power. Okay, because that gives me a 1 here on the left hand side. So my variable is now raised to the first power, and the right hand side is 3 to the 3/5. Now, 3 to the 3/5 is the same thing in its radical form as the 5th root of 3 cubed, which is really the 5th root of 27. It doesn't really do me any good to change it from its radical into its rational form because I cannot take the 5th root of 27 and get a more simplified answer. So this 3 to the 3/5 is the solution for what I'm looking for, and you can always plug that in. Back here we can plug it into our original equation and we can see that yes indeed this is the solution that I wanted.